Okay, so this is M2 Rocks and Minerals. Let me just put this for you, anyone who has been absent or asleep during the other lectures. This is my email address if you have any questions about any of these slides. Please don't hesitate to email me, or you can review these slides on the web page. Hopefully everyone can hear me. I think we were pretty far in this particular lecture last time. Yep, crystal structures, went over that last time. Yeah, so quartz, sulfur. If you remember, we talked about pyrite. This is pyrite. It's the one that looks like gold. It's a mixture of lead and sulfur, but if you scratch it onto a surface, it's not gold, it's gray in color, so that's how you know if someone's trying to trick you as far as giving you fake gold and asking for money. Don't fall for it. Yeah, Mohs scale, this German dude was pretty good. He decided to make a quantitative scale of how hard rocks are. 1 is the softest, and up around 10 is like where diamonds are. Most rocks are around below 7, so if you get above 7 on Mohs scale, you're dealing with really, really hard rocks. Yep, so this is the test you can do with pyrite. This is an example of hematite. It's black, but it leaves a red-brown streak. So these minerals, they have these different crystal shapes. That's a great way to identify them. Also, how they break, cleavage and fracture. Went over this last time. Their color, their smell. This is an example of the different types of cleavage. This would be like some sort of, this is muscovite here. If you've ever heard of mica, it's very common. Pretty cool mineral that kind of comes off in sheets. Calcite is like this crooked square, or like a rhombus type of thing if you're really into geometry and things like that. So, what's up with this? Ores. This is where humans come into play when we talk about minerals. Ores are generally minerals that have kind of precious metals, or sometimes other materials that can be removed in usable amounts. So this is how we as humans make money on minerals, and this has been happening for thousands of years. You can remove these metals from the minerals mainly by smelting, which is where you heat up this big pile of liquid to the specific heat that the metal melts at, and eventually the metal will melt and the mineral will not melt, and you'll get this kind of collection of liquid metal, which then is cooled and then used in construction. Iron is a really good example of an ore that's found in minerals, and then it's smelted in order to form these metals that can be used to build buildings. So you have these other things like sulfur that are minerals, like we saw earlier, the yellow kind of mineral. It smells like rotten eggs. That's how you can kind of tell that it's sulfur. They're used in match heads. They're also used to fertilize fields, and also in some medicines, which is pretty cool. Gems we talked about last time. If you're trying to get someone something nice, you can get them diamonds, rubies, sapphires, and emeralds if you're really kind of wealthy, or if you're trying to just get them something nice, you get them a semi-precious stone like an amethyst or something like that. People tend to like this. I don't know if you guys have heard of birthstones and things like that are usually semi-precious stones, and these are just minerals that have really kind of nice colors and crystal shapes. So we talked about this last time. This is kind of where we left off, these different types of rock. Igneous, okay? And you can kind of think of ignite, like you ignite a flame. Igneous rocks are formed from magma within the earth. And an important thing that I didn't cover last time was that people tend to use the word lava and the word magma as the same thing, but in geology it's important to know that lava is magma that's been released from the Earth's crust. So when a volcano erupts, the red hot stuff that's on the outside of the volcano is lava, and the things that slide along, the tectonic plates slide along underneath the Earth is called magma. So this is kind of like when the magma is released from the volcano, when it blows up out of the volcano, it becomes lava. So just know that when we talk about igneous rocks, we're talking about they're formed from magma that was within the earth. So this magma cools down in one way or another and forms different types of igneous rocks. And yeah, you can see here, igneous actually means fire in Latin. So think of, ignite a flame, igneous. Help you remember that. So this is really connected with a few lectures that we did about weathering and erosion. If you want to refer those slides, you can, but sedimentary rock is just particles or sediments that have been eroded, so they've been moved by either wind or water or glaciers. And then, they can be compacted again. They're either pressure is put on the rock by water or sometimes even human machines or glaciers, things like that. And it forms these rocks. This last sentence is the most important. It says, over time, they are pressed together to form rocks. So the fact that they're pressed together is the biggest part of this entire paragraph here. So I understand that this is really long, but just know that sedimentary rocks are rocks that are formed from sediment, which again we talked a lot about in a couple lectures ago, and they're pressed together and they form different types of rock. We'll talk about that in a second. Okay, this we went over last time. Okay, so chemical sedimentary rocks. This is something that's not generally talked about too much, but I think it's really cool, so I'm going to talk about it now. Basically, the biggest example of chemical sedimentary rock is rock salt, or these salt flats. So this is a famous area in the US where they do races, and they try to set land speed records. So they try to go as fast as they can on land, and this is basically the Lucas rocket car. So this has like a rocket engine on it. So this is like a plane with no wings, and it's gonna be traveling along this is chemical sedimentary rock. This is salt, and it forms in this flat layer, and this is miles and miles of just completely flat landscape. So this is the perfect place to have these super powered vehicles go to try to set speed records, because if there was one rock that wasn't this rock salt, it would make a bump and this thing would go flying, and who knows what, you'd never find it again. So this is pretty cool. I don't know if you guys have seen this before, but you can also look up bicycle records. They have these, it's all on this salt. When people want to go really fast on land, they use chemical sedimentary rocks. This is just kind of a cool connection between how humans tend to use this and what it is. Okay, so organic sedimentary rock sounds really boring, really important. This is where coal comes from. This is also where oil comes from, which is where gasoline comes from. You need to have organic sedimentary rocks to have fuel. And this is the whole reason that we have fuel, is because this organic, which means living, these living things are broken down and they're submitted to pressure. They have things acting with pressure on them, so they're squeezed into these these parts of the earth, and then they form this really energetic substance that if it's burned or if it's turned into certain things, it can release tons of energy. And this is where coal and oil comes from. Coal is when plants die. Lots of plants die. Maybe if you have a big fire or something, and then they're kind of the leftovers are kind of left in the soil, and then say you have a mudslide that comes over that, and over time, thousands of years, the coal is compacted, or the plants are compacted, and it forms coal, which we use to power lots of different machines. Okay, so if you don't remember this, then shame on you, because we went over it a lot in the last couple lectures. This is an example of physical weathering. Weathering is the breakdown of rocks, not to be confused with erosion. So it's if you have a giant rock and you kind of start breaking it apart into smaller rocks, that's weathering. And this is frost wedging. This is a great diagram. During the day, maybe, say it rains, water gets into this crack, and then it freezes. And the ice expands. It's going to be expanding when it freezes, and it's going to be pushing apart this rock. And over time, this creates smaller and smaller rocks. And this is what weathering is. And this is just an example of physical weathering. Another big example is chemical weathering. And here's a diagram of, you have a big city over here, and this is just sulfur dioxide. It's a big pollutant. Hopefully you're familiar with the term pollutant. We went over it a little bit last time, but these specific chemicals, nitrogen monoxide here, and sulfur dioxide, or nitrogen trioxide, these different chemicals are released from these cities. And it makes these chemical clouds, and then these chemical clouds combine with normal clouds, and they produce what's called acid rain. And acid rain can really erode, it can weather rocks very fast. It combines with other elements in the rock, and it makes them break apart and be more susceptible to washing away. This is a huge form of chemical weathering. Also, if this is a little bit complicated, just think about a rusty chain. The rust that you see that forms on the outside of an iron chain is weakening it. That's because the chain is being oxidized, and that means that the molecules that make up the chain are reacting with the oxygen gas, and it forms this kind of rust material, which weakens the substance. That is chemical weathering as well. So just to go back, physical weathering is when these changes happen based on some sort of physical process. They're pushed or broken or pulled. If you have a glacier coming over a valley and digging through this valley and breaking rocks up, that is physical weathering at its best. If you have these chains getting rusty and eventually breaking, or acid rain falling down, that's going to be chemical reaction. And you can also think about this if you have a chemical structure. So say you have our favorite PBS pyrite. Okay, this is the gold, fool's gold. If pyrite went through a process that separated the lead and the sulfur, it would be chemically weathered. If this bond is broken and you have, you're left with some sulfur over here and some lead over here, that is chemical weathering. But if you have a huge chunk of pyrite and it breaks up into several smaller chunks because you have put a hammer to it, or it's been a glacier has come over it and it's been broken into these parts. This is physical weathering, this is chemical weathering. Okay, so definitely know the difference between the two. Cementation, we went over this. It's just basically rocks that are connected by some sort of material that acts like a glue. If you've ever seen broken cement, it's usually, you see this kind of block, and then you've got these like jagged rocks sticking out of the block, and it's kind of bumpy, and you can definitely recognize it. Compaction, we went over that, pressing the rocks together. So yeah, erosion. Again, if you are still confused on this, please check out the erosion lecture, which I did 2 classes ago. So we talked about weathering. So that's the breakdown of sediment into smaller parts. So a big rock breaking down into smaller parts. Erosion is the transport of those particles. So it's the movement of those particles. It's stated here pretty clearly, when the small pieces are carried away. Okay, you've got running water, waves, and you have wind. And if can anyone tell me what's missing here? What's missing? These particles are being carried away. What could carry away something other than running water, waves, and wind? We were just talking about it. It's made of ice. Huge thing made of ice. I've talked a lot about it because I think they're really cool, but glaciers are missing from this. So you have these hugely powerful erosion machines, glaciers. And again, if you don't remember about glaciers, please review the other lecture, or send me an email, or YouTube glaciers, and you'll find some really cool stuff. So there's an erosion and weathering game that I found online. It's really fun. It deals with different types of weathering and different types of erosion. This is the link for it. You can totally look at it whenever you want. Maybe it'll help you. I don't know if it's gonna work. Hopefully it will. But if it doesn't, again, send me an email, and I will try my hardest to get a link that does work. But yeah, just check it out if you're interested. We did that last time. So this is where we ended last time, with the rock cycle. So we've been talking about weathering and erosion. That is the breakdown of large rocks into smaller rocks, and then you have this compaction, cementation. Those are kind of the forces that form new rocks. So you have to be forming new rocks as other rocks are breaking down. Otherwise, we would just have sand everywhere. So if you're moving from large rocks to smaller rocks over here, then you're going to need to move from small rocks to large rocks. And hopefully what you've learned last year about plate tectonics, you haven't totally forgotten, because plate tectonics and volcanoes and these really exciting things are essential to the cycle of rocks. And forming new rocks and breaking down old rocks is kind of what it's all about, and the process kind of shapes Earth as we know it. So we're going to talk a little bit about that. What is the role of plate tectonics? So this might seem familiar to you, hopefully. If it doesn't, don't worry about it. You have these tectonic plates. Just do a little crash course on plate tectonics really quick. They're floating on top of magma, okay? The magma is kind of working its way up in some parts, and as it spews out the top of these, it becomes lava, and this is a volcano. Okay, in the ocean, you have these two tectonic plates moving away from each other. You have these arrows here. Okay, and as they move away from each other, more crust is formed. More crust is formed. The magma cools when it hits the ocean and forms new crust. Some of these crusts are colliding, okay, and forming fold mountains. Some of them are kind of going one underneath the other and forming these subduction zones, which hopefully you went over last year, but if you've forgotten it, don't worry about it. You know, and so what's happening here is we're forming new rocks, and then old rocks are going underneath and melting. So this is crust melting and turning back into magma, and you know, they're coming back up and then turning back into magma. Some of this magma is blowing out the top of this mountain, and then you know, maybe it comes down here, slides down here, it's moved, and then it goes back down. You know, the rocks are you know, continually being formed and being broken down. So that's the key to the rock cycle, is that new rocks are always being formed, and old rocks are always being weathered and eroded. Okay, so here's a pretty simplistic picture. Hopefully this helps you understand the rock cycle. Volcanoes are really important. So you have the volcanic eruption. It forms igneous rock, which is what we were talking about before. Ignite, fire is what it means in Latin. So these are rocks formed from lava that comes out of the volcano. This rock's broken down into sediment. This is weathering. Okay, it's compacted maybe into these sheets. This sediment can also be moved. That's erosion. It's eventually deposited, which we talked about in the other lecture as well, and it forms these different shapes and sizes. You know, you could get minerals from this, you know, but in this example, this is kind of compacted into sheets. Over time, these sheets kind of are weathered, and you have these metamorphic rocks, and then eventually these metamorphic rocks might go back into magma. And then, you know, this magma is spewed out again. It all happens again. And if you want to see a really awesome video about volcanoes, you should check out this link. I just added it today. It's really, really cool. Yeah, this huge car gets completely enveloped in lava. It's really cool. So, and it's got a really cool soundtrack too. So, it's only about 30 seconds. It's on the National Geographic website. Copyright National Geographic. No, I'm just kidding. But yeah, check it out if you're interested. This link is really cool. So this is kind of an overview. This slide is really important. I would definitely save it and look back at it throughout the term. It kind of combines what we're talking about now with the rock cycle and what we were talking about at the last lecture with weathering and erosion. So we have these terms here, you know, that can be confusing at first, but hopefully in this diagram they'll become more clear. You know, this over here is a subducting tectonic plate. So this plate is moving underneath this other plate. Okay, and this is what we talked about before, the subduction zone. Okay, as this goes down, some of this sediment or rock is moved, pushed upwards. Okay, others are melted down here, released. The lava is heated up, and this is magma. It's heated up and forms volcanoes. That's where you get these volcanic mountain ranges. If you remember, we talked about on the west coast of the United States and also along the west coast of South America. This is all subduction tectonic plates, and all the mountains that are on the west side of South America and the west side near northwestern United States is volcanoes. Those are all volcanoes, and they all have this process going on, or has gone on in the past. So this is melting magma that comes up and blows up out of these things and engulfs cars and things like that, like in that video. Some of this is crystallized, okay, and crystallization of magma. This is just forming minerals. Okay, we just talked all last lecture about what minerals are, and we know that they're inorganic solids with a crystal structure, and they have all different colors and shapes. Some are really valuable, some aren't. They've got different smells. You know, you have pyrite like we talked about, sulfur, diamonds. All these things are made in this process, crystallization of magma. And not without going in too much detail, the time that it takes the magma to cool, the time that it takes for it to go from really hot to cold, is a huge factor in what type of mineral it's going to be. So things that cool very, very fast tend to have very small crystals, and things that tend to cool very, very slow tend to have large crystals. So if you see a mineral with the gigantic crystals in it, it probably took a long time to cool down from magma. So then what happens? We have this, you know, you see these rain clouds over here, weathering of rocks at the surface. So we know that this can be either chemical or physical weathering. Chemical, like we said before, being like oxidation from like a rusty chain, or physical, like if a glacier comes and, you know, carves out a valley in the mountains. You have this weathering, which is the breakdown, and then you have the erosion and transport, which is basically the same thing. Erosion is the transport of these weathered sediments, and this can be by rain, wind, water, glacier, whatever. And then, you know, this all just comes back around. It becomes deposited. This is, you know, this is showing different types of rivers. We talked last time about deltas, and how the Nile has this humongous delta, you know, in Africa, and it's this crazy, you know, crazy delta, biggest one in the world, and it produces it deposits all of this sediment, and the sediment is arranged in a specific way, based on what type of deposition is happening, and that's just what way is it deposited. We went over before, if something is falls off of a waterfall, it's gonna look different than if it's coming from a delta like this, or if something has been deposited by wind, it's going to look much different than if it's deposited by water. So then, yeah, you know, you get this deposition. This diagram is showing this sediment going into the ocean, which is really common. And then, you know, as this sediment is compacted by the weight of this water, it's being pushed together. It's being pushed together by the weight of this water, and it forms rocks. And then these rocks can move back down the subduction zone. Okay, and this is called deformation and metamorphism. I would not even worry about these words. You can memorize them if you want to. Maybe I'll do some extra credit words or something, but for now, don't worry about these. They're not used very often in geology. Yeah, so you know, you have this just know that this is where the rocks change. So this is change with this really awesome pen that I get to use. So this is where the rocks really change. They melt down. They get compressed underneath this sliding plate. This subduction causes volcanoes and earthquakes and all kinds of craziness. The rocks eventually melt, and this whole thing happens again. If you're way more confused than when we started, don't worry. We'll go over this again. You can send me an email or review this slide. If you go online and look up just the rock cycle, you can find 100 images just like this. If this one's too confusing, then definitely feel free to do that, and whatever helps you to understand better. This just has some really a lot of words we've been using in the past, so this just kind of connects it with this cycle. Okay. So igneous rocks. So these are the fire rocks that come from magma that turns into lava when it's being spewed or released out of the top of a volcano. You know, are there different types of igneous rocks, and what makes them different? Well, the answer is yes, there are many different types of igneous rocks, and geologists have spent thousands and thousands of hours figuring out all the different types and categorizing them. The main way that they're told apart is by their composition and their texture. Composition is just a fancy way of saying what are they made out of, and texture is just, you know, what do they feel like, what do they look like, the shape, the size, and most importantly the arrangement of the minerals. So these igneous rocks are made of minerals, and how are they connected, how are they fused together to form these rocks, and what are they made out of? Okay, so I'm just going to go over the main types of igneous rocks. We have glassy. You can kind of tell why this is called a glassy rock. It looks kind of like glass. This is obsidian. It forms really sharp edges when it's broken. So you want to be careful if you find yourself in a field of obsidian with like no shoes on or something. Basalt is this kind of really cool, forms these six-sided columns. This is really common, and these actually are just pushed from underneath the earth, and they form these huge areas of these columns. And if you want to kind of picture what this is here, I'm going to show a bigger picture of this later, but you know, if you were a person, you'd be like this size. So these are gigantic. This is an example of fine-grained igneous rocks. So we have glassy, fine-grained. This is a zoom in of granite, which is a really important rock. It's very common. You have these black specks in here. That's feldspar. You have quartz. You have this pink stuff in here, and you can kind of see that these crystals are formed together. And this is very aptly named coarse grain. So these are big grains of minerals that have been kind of glued together over time. And this is the hardest one to remember. This is called porphyritic. But I remember it because it looks just like Rocky Road ice cream. If you want to, well, let me skip ahead here. So yeah, look at that. This looks exactly like Rocky Road ice cream. So porphyritic, I don't know, you can kind of just think about Rocky Road ice cream. I don't know, but you can see how this looks the same. This is just these giant chunks of one type of rock within this other type of rock. Okay, and when you can, this rock is about the size of my hand. So if you look at this rock, you know it's got these big chunks in it. It's probably porphyritic. Okay, so glassy rock. Here's a blow up of this, what I just talked about. It's shiny. It looks like glass, except obviously this is black. Obsidian is probably the most common. So fine-grained rocks, you can't really tell what they're made out of. If you look at them, they have these crystals that are formed together, but you can't see them unless you have a microscope. And this is actually a microscope picture of basalt. And you can kind of see how it has these different types of crystals formed together. Don't worry about this purple. That's like there's some colored dye just to kind of make this more clear. But if you look over here, you have these kind of crystals that are definitely two different types of minerals fused together. But if you look at them from a big view, you can't really tell that they have these crystals. So those are fine-grained igneous rocks. Remember, all of these rocks are formed from magma, or lava as it's spewed out the top of a volcano, or released in some other way. Quartz grained rock, this is my favorite because I really like rock climbing, and granite is a really cool type of rock to climb on. This rock is about the size of my hand as well, and you can see that it's got much smaller grains in it, but you can definitely, with just your eye, you don't need a microscope, you can see that these different crystals, minerals have been kind of glued together over time to form this rock. And here's just a verbal, I just wrote down the definition here. Interlocking mineral crystals, that's just these little crystals. They're roughly all the same size and visible to the unaided eye. And the unaided eye is just your eye without a microscope. So yeah, feel free to look up these words: granite, coarse grained rock, and you'll find other examples of things like granite. And yeah, this is porphyritic, the rocky road type of ice cream rock, and these have huge crystals in them. These little white blocks that kind of look like the white part of the ice cream is, they're kind of just stuck in here, these large crystals. And there's also small crystals in here, but generally it's porphyritic if they have these huge crystals in here. So does anyone know what type this is? Can anyone tell me what type this is? This is the first one we talked about. Is everyone asleep? Can anyone tell me what this is? So that's a good guess, except, it's kind of shiny, right? It's kind of shiny, it's reflecting light. So these aren't really interlocking crystals, these are just like, it's shiny, it's reflecting this light. It's kind of like the first thing we talked about. This looks like, maybe your windshield is made out of this. Granite is a good guess because you have this other part in here, but that's not what this is. This is something else. Any guesses? I guess you guys know I'm probably going to give you the answer if you don't respond. So, yeah, so this is glassy. Okay, this is glassy igneous because it looks like. I know, I see that. So okay, maybe we can go back. Let me. So see, it's shiny. It's reflecting light. This is glassy igneous. Okay, and then this is the basalt. It's dull. It's kind of. Oh, I've been kicked out. They booted me. I'm just waiting for like one student to design some sort of virus to come in. Boot the teacher. It's a good thing you only have 1 week of online stuff, because I feel like you guys figure it out. You're gonna spend way more time designing. Hey, are y'all gonna go eat? Because I'm almost done. You don't mind waiting a few minutes? I was almost done, so. I had like 5 minutes left, so